Good night. This truly Professor Dr. Dolphy Gilpin. Tonight we're taking a look at barium, and let's just highlight it here on partial portion of the periodic table. So we have barium atomic number 56, atomic mass or atomic weight 137.2, and it's just below uh, strontium and radium is below it at atomic number 56, strontium is 38, and calcium is 20. Yes, calcium 20, strontium 38, and barium, the one you're looking at, 137.2 atomic weight and atomic number 56, that is 56 proton. It's in the second group, which is the alkaline earth metal group. So we expect it to have similar properties as magnesium and calcium, which are quite popular and readily available elements even in the high school laboratory. Barium is also popular at the high school standard here. So here we have barium. Group 5 period 5 and group 2. Right. So let's look at some notes on barium here. So here we have barium. Barium atomic number 56 and atomic weight of 137.2. Its most stable isotope would be atomic mass of 130, but let's find out. Going to the notes is electronic configuration or noble gas configuration is xenon 6s2. All right, barium. Okay, our shell configuration would be 2 in the first shell, 2, 8, 18, 18, 8, and 2. That is the shell configuration. That's where you get the 6s2. And it's an alkaline earth metal in a group 2 and period 5. The metal is solid at room temperature, soft, silvery white in appearance. And we have one stable radioactive isotope here at barium 131. Some people listed at barium 130 for that isotope. And the most common form of barium we encounter is stable and not radioactive. I mean, the most common form of barium that we encounter is the stable barium, and that one is not radioactive. Now, barium is in the S block, group 2, alkaline earth metal, and period 5. And the reaction of barium is barium reacts with water to give you barium hydroxide, and it reacts with air to give you barium peroxide. It reacts with water violently, And if you even eat the water, that would be a more violent reaction. But it does react with cold water. Like magnesium, it's more looking like the alkaline metal, like sodium and potassium, but it's not as violent as potassium and sodium that would give metal would run on top with the water with bright flames. But it does react with water to liberate hydrogen. To form barium hydroxide and hydrogen. That is Ba plus H2O give you BaOH bracket 2 and hydrogen. Now barium reacts with almost all the nonmetals, forming poisonous compounds. Barium is used in barium nickel alloys for spark plug electrodes and in the vacuum tubes, or as a drying agent to remove oxygen that is it is used as an oxygen removing agent. Alright, this famous reaction it turns up again, barium plus water, barium hydroxide plus hydrogen. Barium reacts violently in the powdered form in the air. In the powdered form, barium will react violently in the air, and I guess that will give you barium, oxides of barium, including barium peroxide. Now, because of this high reactivity, it is not found to exist alone, but it's found combined with other elements. And barium was named after the Greek bari, which means heavy. It is said that barytite is a brown sulfate that was also used in witchcraft back there in the days, in the olden days. That is barium sulfate. But it got its name from bari, which means heavy in Greek, and that barytite, form of barium sulfate, was used in witchcraft. Now, the abundance of barium in the earth is about 0.0425 in the Earth's crust, and some statistics have it as 0.05. I think 0.0425 would be more precise. You know, when barium sulfate was discovered, it was mistaken for the philosopher's stone. Yeah, when it was discovered, it was mistaken for the philosopher's stone. Now, it is quite flammable and may ignite spontaneously in the air and with water. And yeah, it does react and ignite in the air. It's flammable, and it may react spontaneously as well. Barium has medical use, but it also has some adverse effect if consumed. And we know that the barium chlorides, the nitrates, and the hydroxide is particularly toxic to humans. So barium from barium peroxide on eating barium in the air. So if you eat barium in the air, you'll have barium peroxide, 2Ba plus O2, give you Ba2O2, that's barium peroxide. And a mixture of barium oxide and barium peroxide will be produced. So you also get the oxide and the peroxide on eating barium in the air. And you know, again, that barium plus water with a colder heart. You get barium hydroxide, and hydrogen is also liberated. Barium hydroxide and other corrosive barium compounds may cause chemical burns, and these have to be treated as thermal burns. Barium is highly toxic, and upon acute or chronic exposure, it's highly toxic upon acute or chronic exposure, and you can get chemical burns with the barium. You know that barium carbonate, BaCO3, is a rat poison, or it is used in rat poison, and the percentage of barium carbonate in rat poison is contain about 20 to 25% in the barium carbonate there. The barium carbonate, the barium is also used in paint, ceramics, enamels, rubber, and certain form of plastic. Now, as a rodenticide, or rodent baits, it contains about 20 to 25% of barium carbonate. Now, food containing the barium would be potatoes, lettuce, onions, beans, nuts, fish, and cereals and grain. You may also drink water, groundwater, and contaminated water, as well as surface water that contain barium. And may also breathe barium from contaminated air or dust. All right, we'll continue with barium in just a moment. So let's just stop here. The barium, atomic number 56, atomic weight 137.2, electronic configuration Xeon 6s2.